So I will give you, maybe we can stack question for later if you don't mind. I have two different chapters, so you're going to choose. Either we go for relationship with third parties, so API design, API documentation, best practices, support, stuff like that, or we continue to deep dive into building for performance. So let's do a quick poll. So who's in for relationship with third parties? Raise your hand. That's fine. And building for performance, I guess the rest. Cool. All right. So everybody's still in? All right, let's continue then. One thing you guys said is you're building for performance around the world. So I guess it's a big challenge, like being able to have the same performance, whether it's in France or it's in West Coast US or in Asia or in Australia. So wherever clients are based, you can deliver the same experience. It's not always easy because you test from your location, and so everything works fine. You know, that's that syndrome that I think every developer experiences, and it works on my machine. So how do you scale that problem? Like how do you how do you tackle the performance around the world?
Distribution is key for sure to avoid latency. So you have 15 data centers. I think it's for that. We try also to replicate our platforms all around the world with a Google Cloud Platform to avoid latency. The way we are monitoring this is by reverse proxies. So we have really interesting metrics in reverse proxies where we can see latency done by a query from the request to the answer to the client. And that's a really good way to see where your big clients are, and if your latency with your big clients is okay, is to take metrics from this proxy. On the API side, I mean, it's really a good insight.
So yeah, I will follow on this because the first thing that our users need to deploy your infrastructure in multiple clouds, in multiple continents, is to be able to measure how the requests are running on their infrastructure. And one of the way is to get some measurement from the reverse proxies, because it is the gateway of your request. So on Traefik, we are able to export many kind of metrics on many kind of tools like Prometheus, like StatG, like Datadog, like many kind of tools, and this gives you many possibility to adapt your traffic dynamically around your infrastructure.
So as I said, we cannot improve the engine more than what we have today. It's like super fast, and what had to be improved was the latency between the end users and the actual API endpoint. So we distributed the API in 15 regions, which is more like something like 50 data centers. Remember that we need to have multiple data centers per region. We're actually opening a new region later this year in Middle East, probably Dubai. And the idea is to make sure that every single customer is able to reach the closest data centers that has their data. So this is something to remember, is that we have about 5,000 customers, and all of them are not replicated in all those regions. Pajon, French customer, only in France, while others like Twitch, if you are a gamer, you might know Twitch, they have users everywhere. So we need to provide them with a service that is available everywhere. So what we are doing to route their users to the actual data centers that has machines with their data is relying on a programmable DNS provider. So it's named NS1, and they provide their customers with an API to actually program their DNS resolving, so that when you resolve your appid.algolia.net, you actually got resolved to one of the closest machine that has your data. It's based on GeoIP. From your IP, we understand where you should be, if you're not going through a VPN, but where you should be. And from there, we try to understand which machine is the closest. Not only based on the distance, but we are also working on making something more efficient based on actual peering between locations.
Great. Another question. So, to me, performance is not all in things. So you just mentioned it, like you mentioned it a few times, Sylvain. You're not building with the same performance constraint for everyone. Is there, in your design, when you decide to build for performance, like, do you decide the constraint of performance you're going to put in different endpoints, in different software? Like, are all software equal when it comes to performance, or do you vary that depending on the criticality of the service?
So, of course, it depends on the service. For the search API, it's a no-brainer. It needs to be fast, whatever the endpoint, whatever the feature, whatever everything. And it needs to be asynchronous. Most of the long tasks are actually running in the background, so of course we don't want to block anything. When it comes to all the analytics and the processes that are dealing with our logs, it's super easy. It needs to go way faster than what we are generating. So every day we are generating a bunch of terabytes of logs, and they need to be processed in real time. So every 5 minutes, we process the logs that we have written for the past 5 minutes. Whatever the processing you implement, it needs to be done in less than 5. That's very easy. Otherwise, you diverge, and it's crazy. But then when it comes to the web dashboard, for instance, as I said, we have a bit more than 5,000 paying customers, probably something like 20,000 users, including the free. Okay, 20,000 users is nothing. The dashboard doesn't experience any load. Like, it's not something super critical. We are running it with Ruby, very okay. Even if Ruby is pretty slow, it runs okay.
So we don't have exactly this kind of issue on Traefik because we are just building one tool, but in this tool we have different kind of performance issue, whether you are in one part or another. And for example, if you are working on the pipeline, on the reverse proxy pipeline, obviously you have a real performance issue because you don't want to lose any time at somewhere in this part. But in other part of the code, because we have to be connected to many tools, like orchestrators, like monitoring tools, like logging systems. We have different kind of performance issue based on asynchronous tasks. For example, we have a lot of asynchronous tasks in Traefik. So we have to deal a real different kind of issue whether you are in this area of Traefik. And this is completely different skill that are needed to work on this kind of issue. So yeah, this is also interesting in Traefik that we have this whole different kind of thing.
At Mailjet, for processing, also it's a no-brainer. We have to deliver fast, so we try to have elastic systems that are able to respond to spikes. The problem is more on the analytics side, I think, where we have really different use cases, where we have clients having a lot of small campaigns and clients with a bunch of really big campaigns. And that's where we try to pre-calculate everything. So one major shift we did was we used for analytics an SQL database, which were really good for small campaigns or medium campaigns. where you can have really powerful analytics sub-second. And when it comes to multiple million emails per campaign, it's really hard to have the same performance in terms of API response time. So we tried for that to make things asynchronous and pre-calculate everything we have to show the client. So the dashboard is pre-calculated for those campaigns, and we use a big data pipeline to do that.
Cool. We didn't touch base too much on that, but maybe you can give us a quick tour of what your stack look like. So we talked a lot about infrastructure, but obviously behind the scene, it's powered by database engine, search engine, programming languages, app servers, etc. So maybe you can give us a quick tour.
Yeah, at Mailjet we try to use a lot of open source components. So for databases, it's PostgreSQL, Cassandra for NoSQL. For big data pipeline, we use Kafka and Spark for calculation. We also use HAProxy for HAProxy for reverse proxies. And we are really involved into the HashiCorp community, so we use Console, Vault, Nomad, and all the HashiCorp tools to be able to have something cloud ready. In terms of development languages, we use Golang, a bit of Free Pascal for legacy systems, and PHP for front.
The hosting?
And the hosting is completely now at Google Cloud Platform.
Which is a major shift for François.
Yeah.
It has been 2 years' work from migrating to OVH to GCP. So
from dedicated servers to cloud, so it's long journey.
So yeah, as I said, we are mainly using Go. We have some few web UI in JS also, but in JavaScript. We have a small infrastructure based on DigitalOcean, and we are using Elasticsearch to manage this with Kibana and Fluentd. We use also Terraform a lot from HashiCorp and Packer. We use our CIs online. We are using Travis CIs and Semaphore CI, which is super efficient if you don't know it. And we are mainly based on GitHub. So yeah, we don't manage that much, but we have just a small infrastructure.
So we are relying on 12 providers providing with bare metals machines. We also have AWS for web servers and GCP for all the rest. The engine is in C++. It's actually hosted inside an Nginx web server, so we are not handling all the HTTP complexity of handling and dealing with connection and so on. It's part of Nginx, and we are just a model out of that. The web server, the web dashboard is built in Ruby on Rails, React, TypeScript. Most of the analytics processing is done in Go. We do have some Java and some Scala for the monitoring API. We are doing a lot of JavaScript. And anyway, all the languages of our customers to implement API clients. We do actually use Elasticsearch as well, and Kibana as well, for their ELK stack in order to search into billions of lines of log where the relevancy doesn't mean anything. It's actually pretty good. At Algolia, we're focusing on the user-facing search bar, the one that you have on Google or Amazon, on the one where as you type you want some relevant search results. For that, Algolia is way better. But when it comes to do dashboarding or indexing lines of logs, Elasticsearch is great. It scales very well, and you don't care about waiting 200 milliseconds to get an answer.
That was a... Maybe let's go back to your question. We postponed a few of them. You had one.
It was about the data tier, your persistent layer and the caching layer. So
So question is about caching layer. So we don't do cache. We don't do caching. We are. It's a little bit tricky, but we strongly believe that as soon as you start caching search results, you start having issues. So far, our infrastructure is robust and efficient enough to not be able to cache anything. So if you do twice the same query, you will have twice the engine processing the request. Because we are encouraging our customers to push their data to us in real time, because we want their updates to be processed in real time, we also want their queries to be answered using the very, very fresh data. So we don't do caching at all when it comes to search. When it comes to the website, we are using CloudFront and a few, Cloudflare, sorry. We used to use CloudFront. And with Cloudflare, we have a little bit of caching from here and there, especially with assets and static web pages. Apart from caching, what was the other? Persistent layer. So for the search engine, it's full custom. We are relying on a custom binary format out of a RAID 0 disk. RAID 0, I don't know if you remember what it is like we have multiple disks, but we write one part of the data on one and one part of the data on the other. Which means if one of the two dies, you lose everything. But we don't really care because we have 3 machines, so all of them have the data, and therefore we can afford that. Why do we use RAID 0? In order to increase and improve the throughput. Because you are writing less on a single disk, you can write more. When it comes to the logs, we are dumping that to either S3 on Amazon or GCS or on Google. When it comes to the database, we are using RDS on Amazon. And that's it.
Yeah, so we heard about data centers and DNS going down, also Let's Encrypt. But do you have any examples or stories about when you messed up in the context of performance, like something went really wrong?
No. Never.
We did that a bunch of time when it comes to processing our logs. As I said, every 5 minutes we need to process what has been generated. If you introduce something that will slow down the processing and you take more than 5 minutes to actually process what has been generated in those 5 minutes, quickly you diverge, and we had oftentimes a hard time catching up. Because before being able to catch up, you need to figure out where is the bug, and once you fix the bug, you need to make sure that actually you can go way faster so you can catch up all the delay and the processing that you have not done yet. For the search engine, we haven't been in such a situation. We have learned one thing at the very beginning is that you should have a very efficient rollback mechanism. At the very beginning of Algolia, deploying a new version was all about pushing the button into the continuous integration platform. But in order to get that button, you actually need to compile. Remember that we are doing C++. C++ is actually pretty slow to compile as soon as you start having complex code. So back in 2014, and we actually have a blog post about that issue and downtime, we actually broke the indexing. And what happened there is that whatever addition, removal, or update you would send us, we would fail. It took us 30 seconds to discover the issue, but it took us 8 minutes to recompile the engine with the fix and deploy it. From that time, we have now a single rollback button that just redeployed the previous already compiled version, but at that time we weren't backupping it.
Yeah, I think we have many stories around failures and performance issues, but
Always with a smile.
we have one story where our Google Cloud actually broke something like 30% of our packets from our processing engine to our SMTP out servers, meaning that we were able to process like maybe 10% of our usual traffic. It was a really interesting problem because you are completely stuck at one provider. All your machines have the same issue. So traffic is completely broken for 30% of the packets, so it's random. Latency is random, and the biggest problem, in fact, was to explain to Google Cloud support what was the problem. Because you are using a very specific protocol. We were using IP channels to be able to send our emails from our processing machines to a router. Because when we send emails, we use our own IPs. So we rely on Google Cloud Platform, but we have to send the emails through our own network, so we have our own network. Imagine that you are probably the only client at Google Cloud Platform that is using this tunneling protocol and that is sending emails through Google Cloud Platform because it's completely forbidden. You can't send emails when you are using Google Cloud Platform. The SMTP port is closed. So the only way to be able to tackle the problem is to explain it to Google Cloud. And what were really interesting is that we met one of the Pope of distributed system working for Google in a meetup. And when we had this problem with Google Cloud, we first opened the ticket for sure, but then we had this contact on Google Hangouts because we were meeting a few months earlier. And this guy answered us immediately. And he directly found the guy responsible for this network issue. And we were imagining that the problem will take days to solve. And because we had the good contact at Google, and because those guys are answering their phone, we were able to tackle the problem really quickly. So the question is, for us, it really means that even if you are a small client for a big company, if the company is customer-centric, and the top management of this company is able to understand that if you don't solve your problem, you're almost dead, because if you can send emails for an email provider, it's a problem. It was really a good lesson for us to choose our providers. Having such a good contact with them was really a key.
Yeah. I have a really funny story on this because I remember last year we released a new release of Traefik, and we release many by month, so it's super fun. And this time one of our users came to us and said, "Oh, I think I have an issue with your new release because every instance of Traefik now consumes 30 gigabytes of memory more than the one before." Ouch! What's going on? So the whole team studied the issue, and this was really funny because the issue was that we just changed the name of the cookies that we were storing in memory for stickiness session, and we just increased the name by 2 characters. And as it had millions of connections, it has millions of stickiness connections in RAM, and it were expanding 30 gigabytes per server just for 2 characters. So it was really funny, but it was a fun story.
It's a perfect illustration of what we said earlier. Works at a small scale, but when you go at a large scale, start failing.
Exactly.
Great. We'll give us a break to our guest. I think they did an amazing job tonight, so let's give them a big round of applause, please. I hope you enjoy the format. You had fun time. The party will continue. I think you guys can stay a bit more. Again, I don't want to abuse too much of your time, so feel free to skip to go out whenever you want. We won't. Don't try to retain them, please. Really, I hope you enjoy the format. If you have any feedback, please come to me, whether it's here tonight or tomorrow online. You can contact me at arnaud@sqreen.io, sqreen.io. You can find me on Twitter, Arnaud_Breton, and I'm probably findable everywhere else. So please share feedback. I need feedback on how it goes. Is it too long, not deep enough? Are we covering the right topics? The next one should be happening early April, the 5th to be exact. We're going to have Joel from Auth0. So we touched base on authentication earlier. Maybe you can come back. And so we're probably going to talk about API and security, but it's not settled yet, so I'm not teasing too much. Anyway, I will announce on the Meetup soon. Thanks again to Bluecoders for having us. I've seen the guy moving around. I've seen the guy moving around during the meetup, fixing things, adjusting the camera and stuff. So big round of applause to everyone who did all the background, but will make the recording amazing, I guess. Guys, do you have anything to add tonight? Closing words? Pizza are here, and again, sponsored by Bluecoders. Just a quick shout out. What's the best way to reach out to you guys? If you want to, I think it's in front of you. This one, yeah.
You can reach out on LinkedIn, and otherwise my email is sylvain@algolia.com.
Yeah, on Twitter, for example, LinkedIn or everything
Your
else.
handle is Emile Vauge.
Emile Vauge, yeah.
LinkedIn, email François@mailjet.com, or real mail if you want to put stamps on a letter.
Thank you, guys. Just a quick shout out. We have the API, the doc conference that will happen early April in Mozilla offices. They're close by on the Grand Boulevard. So you can find them at API, the docs, Paris 2018. So I will share the link tomorrow, but it's a cool conference happening here in Paris. So if you're into that, that's a good place to be. And I think it's time to close. Thanks, everyone. Thanks for coming tonight.